today's demonstration, let's first update the system. After updating the system, the command shown here installs Subversion, a version control system. The GNU compiler collection, a build automation tool used for compiling programs, provides OpenSSL, a widely used cryptographic toolkit for securing communications, installs development libraries for OpenSSL, required for compiling software that depends on OpenSSL. These are all necessary packages for compiling Nmap from source code. Next, the command here downloads the Nmap source code, allowing the user to view, modify, and compile locally. Now change the current directory to Nmap, as shown here. Now this command shown here checks the system for required dependencies and sets up configuration files needed for compiling Nmap. Now simply compile the Nmap source code. Thereafter, this command here installs its libraries, documentation, and other components. One can see for himself that after successful run of the command, Nmap is installed. This Nmap is a little different from that installed in the last video and is able to do more functions than that. This way, one can check the installed version and configuration details of Nmap. This command shown here fetches the latest changes from the Nmap SVN repository and applies them to your local copy. Move up one level in the directory structure. Now as introductory command. This command here runs in Nmap scan on scanme.nmap.org, a server specifically set up by Nmap's creator for testing purposes. This command will scan for open ports, detect the versions of services running, and attempt to identify the operating system. The results will help understand the target's network configuration. This command runs an aggressive stealth scan that limits the scan rate to a maximum of 100 packets per second. Notice after running the last two commands that IP address and MAC address are visible, which can be used in many ways like the basic one showed later in this video. Now the same command as earlier runs Nmap scan on google.com to gather detailed information about its network. Google actively blocks unauthorized scans, and running this does not yield useful results. Hence, the scan is blocked. One can notice that the services on their open ports are categorized as TCP wrapped for protection. Such blockings alongside detections have also been covered later in this video. Now let's see a demo use of such IP info. To do that, this command installs JQ, which is used for parsing, filtering, and manipulating JSON data in terminal. It is also worth noting, which many of you already know, that cookies are also data in JSON. This command retrieves geolocation and network information for the IP address of google.com, using curl to fetch JSON data and JQ to format it. Thereafter, this Nmap scan is designed to stealthily probe all 65,535 ports on the target IP of google.com while saving the results to a file. But this scan was unsuccessful because of the TCP wrap, as already pointed out earlier in this video. This command shown here does the same as earlier one, but saves the scan results in grepable format for easy parsing. This command again does the same, but saves the output in XML format, which is useful for automated processing and integration with other tools. Now this command is used to show contents of the scan_log.txt file with details about open ports, services, and other network info. Similarly, this helps extract details specifically about open ports from your scan results. Like earlier commands, this is to display the contents of scan_log.xml. This helps in filtering or parsing with XML tools. Now run this command again to notice that the ports are blocked. Similar blockings have also been put in place by the creator of this video, which is demonstrated next in this video. This command lists iptables rules like chains of input, forward, output, including packet and byte counts, displaying IP addresses instead of host names, and adding rule numbers to make it easier to modify or delete specific rules. This command is meant to flush or delete all rules in the input chain. Similarly, this command will flush or delete all rules in the forward chain. Consequent upon flushing, running this command again shows no such rules as earlier. After the previous flushing, this command restores iptables rules from a saved configuration file. This is useful for going back and forth with such blocking. One may also find detection of these scanning alongside blocking of these scanning to be important. So this aspect is also demonstrated next in this video. For such blocking and detection, as earlier mentioned, firstly, this command installs dump, which is a powerful packet capture tool for network analysis. Then this command instructs dump to capture traffic on F0, but only for specific ports. Secondly, this command installs iptables, which is the Linux firewall management tool. Now this command adds a new rule to the firewall's input chain that logs packets with an invalid connection state, which uses the connection tracking module to inspect packet states, matches packets with an invalid connection state, logs these packets instead of dropping them, and adds a custom prefix in the system logs to help identify potential scanning attempts. Following the earlier command, this command checks and displays the system's kernel logs for entries that match Nmap Scan Detected, which was set as the log prefix in the previous iptables rule if the firewall logs such a scan attempt. Now this command creates the file if it doesn't exist or updates its timestamp if it does. This command modifies the file permissions, where 6 is for owner to read and write, 4 is for group to read, and 4 is for others read. Now this command adds a rule to block packets with suspicious TCP flag combinations, especially packets with no flags, meaning null packets, which are sometimes used in stealth scanning techniques like in map scans to probe systems. Blocking these packets helps prevent reconnaissance attempts. Similarly, these two commands add rules to the iptables firewall to drop incoming TCP packets that have both the SYN and FIN flags set, and that have both SYN and RST flags set. Normally, a SYN packet is sent at the beginning of a TCP handshake, while a FIN packet is used to end a connection. A packet with both flags set at the same time is unusual and often associated with stealthy port scans or potentially malicious activity, whereas RST flag used to abruptly terminate a connection. By dropping these packets, you reduce the chances of attackers probing your system. Thereafter, this command adds write permissions to the /etc/ directory for its owner, group, and others, in contrast to the earlier command for write permission to owner. This command saves the current iptables firewall rules into a file called /etc/iptables.rules, ensuring they can be restored later, which is already demonstrated earlier in this video. This command is for opening a file and setting up script as shown to automatically restore the iptables rules before the network interface comes up. After writing the script, the file is saved with Ctrl+O followed by Enter and then Ctrl+X. After the above, this command ensures the system can execute the script when needed. Now thirdly, for detection of Nmap scans. This command is used in Linux-based systems to install PSAD or Port Scan Attack Detector. This command is used believing existence of systemd service file to enable PSAD to start automatically at boot. But it failed because this older service still relies on sysv style in its scripts. This command is to start the PSAD service using the sysv init system. Now this command is to verify if PSAD has started successfully. Now this command is used to configure PSAD to start automatically at boot using sysv init scripts. Since your system redirected system to enable SAD to systemd/sysv install, this command ensures that PSAD is properly registered in the default run levels. But on trying to reload its configuration files, it showed error in part as to daemon. To fix the error, this command is for editing the PSAD configuration file and setting enable_SADWatch to Y to enable the SADWatch daemon, which is responsible for monitoring and restarting PSAD if it stops unexpectedly. This command is to restart PSAD for the changes to take effect, but the error shown here is due to hostname. So, to fix this error, this command repetition is for editing the PSAD configuration file and changing the hostname value in /etc/sad/sad for PSAD to match the system's identity. This helps PSAD correctly identify the machine in logs and alerts. Now, this command is for creating the missing directory that PSAD expects for storing its PID files. This command is for creating an empty PID file for the SADWatch daemon. This can be useful if PSAD expects the file to exist but fails to generate it automatically. Now this command restarts all PSAD daemons successfully. Thereafter, this command adds a logging rule to the input chain in the firewall settings, so that any incoming packets are logged in /var/log/syslog or /var/log/messages, depending on the system's logging configuration. Similarly, this command does the same as previous one, but for forward chain. After the above, this command is used to save the current iptables rules. This command repetition is used to reconfigure PSAD to start automatically at boot using sysv init scripts. Restart all PSAD daemons again. Restart the PSAD service. Reload its configuration files. This command is to display the contents of the fw_check log file, which is used by PSAD to analyze firewall rules and detect potential security threats. Since there's no such attempt and the creator has already set up SYN, FIN, etc. drop rules and iptables, PSAD never sees those packets, making detection ineffective. In case of an actual attempt, one may prefer to fix this by adding rules for logging those packets before dropping them. This command lists all iptables rules and filters the output to show only rules that include the log target as required for previous command. This command is with typo. Sorry for that. Anyways, this command is for yet another iptables rules to log incoming packets, as shown in the second last command. This command is with typo again. Sorry for that also. This command is for yet another iptables rules to log packets being forwarded through the system. This command again is for saving the current iptables rules. This command repetition is used to reconfigure PSAD to start automatically at boot using sysv in its scripts. Now, this command, as an alternative to that for fw_check command, will continuously monitor the system log /var/log/syslog, filtering out only lines containing PSAD. It's useful for real-time observation of PSAD activity, such as detected scan attempts or firewall interactions. Ensure that PSAD correctly applies the latest changes. Ensure that all the updated firewall rules and configurations take effect properly. This command for quick overview of detected threats is showing nothing because there is no such attempt as yet, and whatever the real-time system log showed above was a forward chain only. This command again is also showing nothing for the same reason already mentioned. Now, this command for more clarity is in furtherance of real-time logs of packets with malformed or suspicious TCP flag configurations, often associated with stealth scans or malformed packets sent by attackers. Thereafter, these command in series again do the same as earlier. Now, this command, followed by addition of shown lines to the end of the file, is to customize system logging behavior and redirect specific log messages to different files. In this case, the creator is setting up custom logging rules for kernel messages and iptables logs. After the above, this command ensures that the new logging rules take effect. Without restarting, changes won't be applied. Thereafter, this command and change of file as shown ensures that PSAD reads firewall logs from your custom syslog file, which is /var/log/syslog.log, instead of the default that was /var/log/messages. Lastly, these commands as earlier are meant for same purposes, and they showed such results for reason already mentioned earlier. That's it for today. Hope this video was useful, and if so, please do like this video and subscribe to this channel for more of such videos in future. Thanks for watching.